Okay, so next property is, suppose when we have remainder of 20 into x into y into z. See here, if you see that if the numerator number is perfectly divisible by a denominator number, so which means that 10 to the 20. Okay, so what is the remainder when 20 is divided with 10? So this part is quotient only, but we are talking about the remainder. So 10 to the 20, what is the remainder will have? 0 is the remainder. So when 0 is the remainder, so 10 to the 20, so we are writing remainder here. What is the remainder will have? 0 is the remainder. And no matter what we have the other numbers, so 0 into any number is what? 0. Okay, so you remember this property. Remainder of any number, so let's say that some 48 into some 16 into 7 into 91. Okay, when I divide with, what is, if I ask you that what is the, let's say that 24. So when I'm having a number 48 into 16 into 7 into 91 dividing with 24, if one of the numbers in the numerator is perfectly divisible by the denominator, so we are not finding out the quotient part, only we are finding out the remainder. So please remember that. So what is the remainder will have? 0. So 48 by 24 means that the remainder is 0. So 0 into any number is what? 0. And even we have any numbers apart from this main number, so the remainder part is always 0, because 0 into any number is 0. Okay, even if you take another example, so here what is the remainder when 2, 3, 4, 6 into 86 into, so some other numbers product, when I am dividing with 43, see 86 is divided with 43 completely, right? So what is the remainder I'll get? So the remainder is 0. When I have the remainder 0, 0 into any numbers is what? 0. So which means that what is the remainder? 0. Here the point is, if in the numerator, if one of the numbers in the numerator is perfectly divisible by the denominator, so then the complete remainder is what? 0, irrespective of the remaining numbers in the product. Okay, so that is another property. And next, if you see the next one, so let's take that what is the remainder when 22 is divided with, so the next one is, so what is the remainder when 22 is divided with 8? So what is the remainder when 22 is divided with 8? 8 to the 16, right? So 8 3 is a 24, which is more than 22. So that's why I just confined to 8 to the 16. 22 minus 6 means that what? Yes, 22 means minus 6 means that 6. Okay, when you take 22, 8 to the 16, 12 minus 6 is what? 6. The remainder is what? 6. Now, suppose if I ask you the next one is remainder of 11 by 4. What is remainder of 11 by 4? By using this, we can say the one something. So like 2 11s and 2 4s. You can simplify it. Okay, so 2 11s, 2 4s. And when I am asking that, so what is remainder of 22 by 8? So 2 11s, 2 4s. 11 by 4. What is the remainder 11 by 4? 4 2s 8. The remainder is 3. So don't take that 6. For 22 by 8, the answer is not 3. That means that what I am saying here is, so you should not simplify it while finding out the remainder. Okay, when I have remainder of 22 by 8, the direct remainder is what? 22 by 8 means that 8 2s are 16. The remainder is what? 6. Okay, you should not simplify this form and then find out the answer. If I simplify it, so you can take that remainder of 11 by 4 is what? Remainder of 11 by 4 is 4 2s are 8. The remainder is what? 3. Okay, so if I take this 2 11s, 2 4s, then the answer is 3. So here the point is, you should not simplify the given numbers and then find out the remainder of the simplified form. You should always directly straight away take the original numbers only. When I am asking you to find out the remainder of 22 by 8, you should simply take the remainder of 22 by 8 only. That is what? 8 2s are 16, 6 is the remainder. You should not supposed to simplify this and then find out the remainder. That is wrong, because when you simplify the number, so 2 11s or 2 4s, so the remainder is what? 3. Okay, so 11 by 4 remainder is 3. See, here we can say one thing, that is what? So 22 by 8 means that, so by which number we are simplifying, which number we are dividing? So 2 11s are 2 4s are, which means that in the numerator and the denominator we are dividing with 2. The same thing we can go with the remainder. So 6 divided by 2 means that what? The remainder is 3. Okay. My point here is clearly, so we cannot directly write the remainder, and we cannot take the simplified form of the remainder. Only we divide the number and then take the remainder. But if you take the simplified form, so you can always remember that by which number you are dividing in the numerator and the denominator. For the final number we have to divide with that number. Here I am dividing, here I am taking the simplified form of 11 by 4, which we are dividing with 2 on the numerator part and the denominator part. So since I am dividing the complete number with 2, the same thing would happen with the remainder. So remainder of 6 divided with 2. So what is the remainder? 3. So which means that remainder of, when I have remainder of 88 by 16, we should directly find out the remainder. 16 5s are 80. What is the remainder? The remainder is 8. Okay. But from 88 by 16, if you simplify it, okay, so you can say that 8 11s are 8 2s are. Since we are dividing with the 8, for the previous number if you divide with 8, the remainder is what? 1. Is it clear? You also need to remember this point. You cannot simplify this one, you cannot simplify directly here and then find out the remainder of the simplified form. That is wrong thing. Okay. Here you directly take the numbers and find the remainder, or if you supposed to find out the simplified form, the remainder, then for this number only, so divide with this number. Okay, is it clear? Okay, take the next one. Okay, the next one is the next properties of the remainder is, when we have the remainder, so let's say that 4765, when I am dividing with 10, what is the remainder? If I ask you that what is the remainder, then you don't need to completely divide this part with 10. Okay, so when we are dividing with 10, the last digit is your final remainder. The last digit is your final answer. So that is nothing but what? Remainder 5. In the unit digit we have 5. And similarly, suppose if you are dividing any number with 100, the remainder is the last 2 digits of the numerator. What is the number? 43. Is it clear? So when I am dividing any number with 100, the remainder is the last 2 digits in the numerator. So which means that the final remainder depends on the number of zeros in the denominator part. If we have 1 0, that means that only if we have the 10 multiples in the denominators. Okay, while finding out the remainders in the denominator part, if we have the 10 multiples, so it depends, the answer finally we can write simply like, if the number 0 is only we have, then the last digit of the number is your remainder. So if we have 2 zeros, the last 2 digits is your answer, that is your remainder. Suppose when I have 867894, when we are dividing with 1000, so since it is a 10 multiple, the final remainder is how many zeros we have? 3 zeros. So which means that, so we have to take 894. So this is your answer, right? Let's take another number. Suppose if I have the number 457642 and dividing with 10,000, if the denominator part is 10 multiple, then directly the remainder is nothing but, see, just have a look on number of zeros in the denominator part. How many zeros we have? 4 zeros. That means that the last 4 digits is your answer, which means that what is the remainder? 7642. And which is a very, very useful one, and we will use it in different problems. So just please remember this one. If you remember this one, so it is a quite handy to you. So you don't need to divide the complete number with this 10 multiples. Okay, this is another property. And let's do it another property. So here, so the properties are over. Now the properties are over, and we have been asked different kinds of questions related to the remainders. And again we had different theorems, very important theorems related to the remainders, and all the theorems and all the remainders concept we will learn it in this session. Okay, the most important theorem is in the remainders concept is Wilson's theorem. Okay, the name is not important. Wilson's theorem is important. The problems on the Wilson theorem are very important, and it is also a very simple thing. And by the way, the name is not important. Property is important. The theorem is important. The theorem is, if you are asked to find out the remainder of any number, okay, So when we have a denominator which is a prime number, in the numerator factorial number is given and which is 1 less than the denominator, then the remainder is minus 1. Okay. So you take any number. So if I ask you, suppose what is the remainder of, okay, you're asked to find out what is the remainder of 6 factorial by 7. Remainder of 6 factorial by 7. If you remember the Wilson theorem, then you can immediately find out the remainder of this question. Okay, what is the remainder theorem? When the denominator part is prime number and the numerator part is 1 less than the denominator and with having factorial term, then the remainder is minus 1. Okay, so the remainder of p minus 1 factorial divided by p, where p is a prime number, then the remainder is what? The remainder is minus 1. Okay, here suppose if we have the denominator, in the denominator if you have a prime number and the numerator part is what? 1 less than the denominator and also having factorial, then immediately without second thought our answer is what? Minus 1. The remainder is what? Minus 1. See, for example, if I take that 6 factorial by 7, you carefully observe the problem. What is the denominator part? Denominator part is 7, which is a prime number. And what is the numerator part? So 7 minus 1, that is 6 factorial. Then immediately our answer is what? Minus 1. What is the remainder? The remainder is minus 1. The remainder is minus 1. But as I mentioned already that, so remainder should always be taken in terms of positive. Okay, we should always express our reminders in the positive values. Since the remainder is minus 1 and we have already find out that reminders, negative reminders to positive reminders, and let's say that, so see minus 1 I am dividing with which number? 7. So minus 1 when you take it with 7 zeros are 7, even it is further exceeding minus 1, so I have to take minus 1 here. So it becomes minus 7, minus plus 7 minus 6 is what? 6 is the remainder. And you remember one point, when we have a negative number, so negative number, negative remainder, when we are dividing with a smaller number with the larger number, the final positive remainder is larger number minus smaller number. For a negative remainder, for a negative value, minus smaller value by, okay, so negative smaller value divided by a larger value. The remainder is, positive remainder is always larger minus smaller value. Okay, suppose if I give you that different example, then you will understand. Suppose when I say that minus 4 by, or let's say that this simple example, minus 1 by 6. I want to express, this is the remainder. What is the remainder of minus 1 divided by 6? Minus 1 by 6, even if you get a negative remainder, always remember that we always have to express it in positive reminders. When I have it like this, then immediately do it like this. So minus by positive value. So now you compare these two values, 1 by 6 means that smaller value by larger value. Then immediately you can say that 6 minus 1, which means that larger value minus smaller value is your final answer. 6 minus 1 is what? 5. 5 is your answer. Suppose if I take some number, what is the remainder? Minus 2 by 7. Okay. When we are dividing a negative number with a positive number, and when you are supposed to find out the remainder of such numbers, and even if the numerator part is smaller number and the denominator part is larger number, your final answer is simply you write 7 minus 2. 7 minus 2 is what? 5. You take any example. Remainder of, suppose when I say that minus 10 divided by 20. Minus 10 divided by 20. Okay, so here we have a negative symbol. We are dividing a negative value with a positive value and we are supposed to find out the remainder. If this number is smaller, which means that smaller numerator and the larger denominator, then final positive remainder is simply take the denominator minus numerator. So 20 minus 10 is what? 10. So your positive remainder is what? 10. Okay. So similarly, when we are dividing minus 1 with 7, so because the final value as per the Wilson theorem, what is the final remainder? The final remainder is minus 1, but we cannot express the remainders in the negative terms. So we have to express it in the positive terms. So minus 1 by 7 means that 7 minus 1. So smaller number minus smaller number, sorry, larger number, which is what? 7 minus 1 means that the final answer is what? The final remainder is 6. Okay. So remember that. So P is in the denominator, numerator P minus 1 factorial. Okay. Then the final remainder is what? Minus 1. Let's have a look on another one. Remainder of 10 factorial divided by 11. Remainder of 10 factorial by 11. And all you have to look at is only the denominator part. If the numerator is 1 less than the denominator and that two numerator have the factorial term, then immediately we would say that, so this is a prime number and the numerator term is 1 less than the denominator and we have the factorial. So immediately remainder is what? The remainder is minus 1. But we should always express it in terms of positive values. So minus 1 by 11 means that, smaller by larger. So the answer is what? 11 minus 1. So what is the final answer? The final answer is 10. Okay. And similarly, if you take this remainder of 16 factorial plus 17, 17 is which number? Prime number. Numerator is 1 less than the denominator and we have the factorial term. Then immediately answer is what? Answer is minus 1. But since we have to express in terms of the positive value, so minus 1 by 17 means that 17 minus 6, 17 minus 1. Okay. So what is the positive remainder? The positive remainder is 16. Okay, the positive remainder is what? 16. Is it clear? Okay, next. You take the next problem. So remainder of 72 factorial plus 8 by 73. Can I split it like remainder of 72 factorial by 73 plus remainder of 8 by 73? Because you know the property, when remainder of a plus b is dividing with the same divisor, let's say that c, we can write it as remainder of a by c plus remainder of b by c, right? So now remainder of, now if you take this example, remainder of 72 factorial by 73. Again 73 is what? 73 is a prime number and this number is 1 less than the denominator, we have the factorial. Now minus 1 is the remainder. So minus 1 by 73 means that what? 72. And so the problems on Wilson theorem are very, very important. So these problems were asked in previous year papers in different exams, and there are high chances that these questions will be asked in your exams also. Okay, that's why you concentrate on theorem. And the reminders concept is very, very important. Okay. So by the way, 72. So 72. So that is for this part plus remainder of 8 by 73. 8 by 73 means that a smaller number by larger number, right? When a smaller number is divided with the larger number, what is the remainder will get? Smaller number always. So which means that 8 by 73 means that what is the remainder will get? 8. 72 plus 8 means that what? 80. But we are dividing with which number? 80. So that's why we have to one more time divide with 73, because the remainder is always less than the divisor, right? So since we are dividing the whole problem with 73, the final answer is 80, so which means that it is exceeding 73. So further again divide with 73. 80 by 73 means that what is the remainder I will get? The remainder is 7. 80 by 73 means that 73 ones is 73. So the remainder is 7. Okay. Now if you take the next problem. Let's take the next problem. Again remainder of 100 factorial c. Remainder of, I am writing here only. First you take this part, remainder of 100 factorial by 101. So this is a prime number and this number is, numerator number is one number less than the denominator. So which means that what is the remainder I will get here? So the remainder is minus 1. And again if you split it, minus 5, again minus 10 by, I write one more step. So then you will clearly understand it. 100 factorial by 101 minus remainder of 10 by 101, right? Okay, this is how we split. Even when we have all positive values, negative values, remainder of a plus b plus c by d, or remainder of a minus b minus c, in any case we know that we can split the remainders part, right? So remainder of 100 factorial divided by 101. So this is a prime number and the numerator number is 1 less than the denominator. So immediately this number is what? Minus 1. And also what is minus? Here I have the symbol minus, right? Minus remainder of 10 by 101. 10 by 101 means that smaller number by larger number always gives the remainder smaller number. So 10 minus 1 minus 10 means that minus 11. So so the final answer would be what? Remainder of minus 11 divided by 101. Again, smaller number, when we have the smaller number by larger number, that too we having a negative value, and to convert into a positive value. So what is the answer? The answer is 101 minus 11, right? 101 minus 11 means that 90. Okay, minus 11 by 101. We know the rule that, so see, which means that here if you look at this one, so negative reminders concept, so remainder of minus 1 by 6, minus value by positive value, okay, smaller value by larger value means that directly you can take 6 minus 1, directly you take 7 minus 2, negative number by positive number and negative smaller number by larger number means that, so larger number minus smaller number, okay, so which means that, so here we have minus 11 by 101, so 101 minus 11 is your answer. So what is the final answer? 90. So the final answer is 90, the remainder. Okay, so this is Wilson theorem number 1. Now theorem number 2, and you have to find out. So in the previous problem, so the condition is the denominator part must be the prime number. So we have the problems, so where the denominator part is also a composite number. So if the composite number is given, then the rule is remainder of n minus 1 factorial by n, where n is what? A composite number. If the denominator part is a composite number, in the earlier cases we have seen that the denominator part is what? A prime number. Suppose if we have the denominator part as a composite number and the numerator number is 1 as usual like the previous case. So if the numerator part is 1 less than the denominator, then the final remainder value is what? The final remainder value is 0. Okay, so this is Wilson theorem number 2. And you just remember that even it is also a very important one, where n is a composite number and also there is a condition that it is satisfied and it is proven only for the numbers which are greater than 4. That means that of course 2, 3 are prime numbers anyway. If the denominator part is 4, it is not satisfied. Okay, so the rule is not correct. So that's why the condition is where n is what? Greater than 4. Okay, you keep an eye on it. Okay, here for example, if I take what is the remainder when 9 factorial divided by 10 is given. First you just understand the denominator and you just have a look on the denominator part. So what is this 10? This 10 is a composite number. In the numerator part, so it is 1 less than the denominator. So 9 factorial by 10 means that what is the remainder we'll get? Immediately the answer is 0. Okay, so just if we have the denominator part is a composite number and the numerator number is 1 less than the denominator and having factorial with that, then immediately answer is what? The remainder is 0. The remainder is what? 0. So this is what the theorem states. So remainder of n minus 1 factorial divided by n where is equal to 0, where n is equal to what? Composite number, and n must be greater than 4. So now we take another theorem, theorem number 3, extension of Wilson theorem. Wilson theorem, so basic one, Wilson theorem, theorem 2 and Wilson theorem 3. In this theorem we have p minus 1 instead of numerator p minus 1 factorial. Suppose if I have the p minus 2 factorial in the numerator, so here the concept is remainder of p minus 2 factorial divided by p is 1. Okay, suppose if you have a look on the example, here what is the remainder when 5 factorial is divided with 7? So as per theorem 3, the denominator part must be a prime number and the numerator part is 2 less than the denominator. The numerator part is what? 2 less than. In the earlier case, in Wilson theorem 1, we have prime number in the denominator and the numerator part is what? Only 1 less than the denominator and having the factorial. So now Wilson theorem 3 is, again we have the prime number in the denominator, but the difference of the numerator and the denominator is what? 2. Okay, so here 5 is 2 less than the 7, then immediately answer is what? 1. Okay, so just remember the theorems because these theorems are very, very important. Without having these theorems, it is very, very difficult to find out the answer for these questions. Okay, now look at the next one. What is the remainder when 9 factorial is divided with 11? Okay, what is the remainder when 9 factorial is divided with 11? Again, if you look at the denominator part, what is the denominator part? The denominator part is 11. 11 is what? A prime number. And 11 minus 2. So the denominator part minus 2 is the numerator. If it is like that and factorial term is given, then the final answer is what? Then the final answer is 1. Okay, so this is Wilson theorem number 3. And these 3 theorems are very, very important. So please remember them. And we have even more number of problems and more different kinds of problems we have in the reminders concept. That we will see it in the next session. Okay, thank you.